welcome to this lesson. We are going to look at GIS and especially GIS in meteorology. So what is GIS? What is meteorology? To understand that term better. And how is GIS used in meteorology? So let's look at what is GIS. GIS stands for Geographic Information System. So the G for geographic, I for information, S for system. So geographic refers to the Earth's surface and anything that can be located on it. Information. This refers to data, facts, and details that are gathered. And system refers to the computer, software, and hardware, as well as the people, processes that work together to handle geographic information. It's important to note that it's a computer-based system designed to capture, store, manage, analyze, and display all types of geographical reference data. Essentially, it allows you to visualize, question, analyze, and interpret data to understand relationships, patterns, and trends in a spatial context. So think of GIS as a powerful digital mapping tool that goes far beyond just showing where places are. It allows you to layer different types of information like population density, rainfall, roads, elevation, land use, and the list can go on. So layering that information on top of a map to see how they relate to each other. And this information helps geographers in 4 ways. So, firstly, to identify questions and issues. So, for example, where are areas prone to flooding? They can see that using GIS. Or, where is there a high concentration of a particular disease? They use it to collect and structure information. So, gathering data from various sources like satellite images, aerial photographs, surveys, and existing maps. Then process, interpret, and evaluate that data that they've gathered. So analyzing the layers of information to find patterns, relationships, and trends. And then lastly, to make decisions and judgments, using all the information that they've gained from GIS to propose solutions or geographical problems like urban planning or disaster management or resource allocation. Now, what is meteorology? You have heard this term before, but let's look into it, what it really means. So, meteorology is the scientific study of the Earth's atmosphere and its phenomena, with a primary focus on understanding, forecasting weather. So a meteorologist will study weather patterns, climate change, and specific atmospheric phenomena like air pollution, cloud physics, or severe storms to deepen our understanding and improve forecasting models. So in essence, meteorology is crucial for our daily lives because it informs us on multiple things. Everything from what clothes to wear to critical decisions about safety and resource management. So for example, if you know the weather is going to be really, really bad, or there's a risk of flooding or fire or whatever the reason might be, that information you need to make decisions. So what does meteorology entail? Atmospheric phenomena. This includes everything from everyday weather, like the clouds, the rain, the wind, the sunshine, to the more severe events like thunderstorms, tornadoes, or hurricanes. Scientific principles. Meteorologists use principles from physics to understand atmospheric composition and pollution, and they also use mathematics and complex models to analyze and interpret processes. Observation, understanding, and prediction, collecting data from various sources. Understanding, like to analyze all the data that they've collected on how the atmosphere works and the weather systems between all the interactions of land, atmosphere, and ocean. And then prediction, your weather forecasting, using all of this information to predict future weather conditions. So, how does GIS work in meteorology? So, they use it for data integration and mapping, which means GIS combines various weather data sources from satellites, radar, or weather stations and display them on accurate layered maps. And this creates a clear weather maps you see daily, showing the temperatures, the precipitation, whether it's snow or rain, wind and storm tracks. It's also important for spatial analysis. It allows meteorologists to find patterns, estimate conditions between weather stations, and combine different data layers, for example, rainfall with elevation, to identify flood-prone areas or predict a wildfire spread. For forecasting and impact assessment. So GIS visualizes and helps interpret output from complex weather models. It's crucial for assessing the potential impact of forecasted events by overlaying predictions with vulnerable areas. For example, a hurricane's path over a populated region. You need that information to warn the people, for example. Disaster management. So GIS is vital for early warning systems, planning evacuations, and allocating emergency resources during and after severe weather events. With GIS, they can see beforehand if there is a disaster coming, so they can warn people. Climate research. It's used to analyze long-term climate trends and model the potential impacts of climate change on various systems. Now, these images is from the South African Weather website, and we've talked about synoptic maps, and this is how it will look like in a visual image of South Africa. These are taken at the exact same time, so you can see this visual image and how it will look as a synoptic map. So let's analyze this visual image. So we focus on South Africa with this map. Okay, so South Africa mostly in this image shows clear skies across the landmass, so the land, indicating no significant cloud cover over most areas, including Cape Town at this nighttime. So this image was at nighttime, so the interpretation, there's no major cloud cover as you can see during that time. Off western coast or off the west coast of Cape Town, a large powerful cold front or mid-latitude cyclone is clearly visible approaching from the southwest. So that you can see here. And here in a synoptic map you can also see the cold front approaching. The bright yellow, orange and red colors show very cold, high cloud tops, signifying intense rainfall and strong winds associated with this system. And the system is heading directly for the Western Cape. So it is a low pressure system. So they talk about very cold, high cloud tops, intense rainfall and strong wind, which comes with a low pressure system. So the primary weather concern for South Africa is the approaching intense storm from the Atlantic, set to impact the Western Cape. Most of the country is clear, as you can see on that map. So here you will see more of a moving visual of this, how the image moves in a video.